Hello and welcome to this month's PolyWise webinar. Today's subject is going to be volume measurement both on PolyWorks Inspector and Modeler. And as it's St. Patrick's Day, we're going to be analysing one of our favourite exports from Ireland, which is Guinness. So I have a can of Guinness that I'm going to be scanning today using the arm. And then we're going to analyse the volume using that measurement data. If you have any questions throughout this webinar, feel free to post it on the live chat we've got going, and one of our operators will be able to answer that as soon as possible. So let's get to it. Okay, so we've scanned our can using real-time quality meshing. So first of all, I scanned it in the upright position like this, and I also scanned it a second time in a horizontal position, trying to get as much data as possible so that I can align those two bits of data using a best fit data to data object alignment. Once that data is aligned, I then cleaned it up and meshed it together to create a single polygonal model. With this polygonal model, I then aligned it to a coordinate system and brought it onto PolyWorks Modeler Lite, which you can see here. So PolyWorks Modeler Lite, for those who don't know, is if you have a Inspector Premium license, you actually have access to this Modeler Lite software where you have some basic functions to do with optimizing your polygonal models, such as hole filling and analyzing the volume here. So you can also do this using a normal seat of Modeler, where you'll obviously have a lot more tools at your disposal. What I did is I brought it onto Modeler Lite and performed some basic optimization processes and hole filling. If you'd like a more advanced guide on how to do that, please see our last webinar that we did, which was Mending a Broken Heart, where we went through those mesh optimization techniques. But what we're doing today is measuring the volume of this model. So on Modeler, you have your measure volume tool up here. So you can measure the volume over here, and in order to measure the volume of this can, simply click this tool and it will give you the volume in whatever units your project is created in. So you'll notice it doesn't state the units here, so whatever units your project is in will be what this is measuring in. So you'll notice in order to find out what units you're actually measuring in, you can set that in the options. Or also, if you go to the bottom right hand side of the screen, you can see I'm measuring in millimeters down here in the bottom right hand corner. Ideally, you want to have a watertight model to analyze its volume. So in my case here, I do have a watertight model. You can check the watertightness again with a tool similar to this, which is Analyze Watertightness here. So when I click this, you can see it tells me that the visible part of the model is watertight, and you'll see that, for instance, if I had a hole in this, so I'm just going to select some elements to create a hole. If I go back to that watertightness tool, it'll actually give me the amount of boundary triangles on this particular model that need to be filled. And you can also see that I can do a volume measurement as well, but it does say the triangle selection is not watertight, therefore the volume may not be exact. So you will lose some accuracy in your volumetric measurement if you don't have a watertight model. In Modeler Lite, those tools live up here. If you were using a normal seat of Modeler, you may need to find them under Polygons, under Analyze, and you should have your volume and water tightness measurements there. Okay, so this is how you measure volume of a polygonal model on PolyWorks Modeler. So that is the tool that we have available to us there. But we do have a more robust and specific tool for it on Inspector. So what I'm going to do is I'm going to undo this delete here. So just going to press undo a couple times in order to, and then unselect all those elements. And I'm going to bring this scan and our model back into Inspector. So to do that, I'm just going to come to my polygonal model here. I'm going to right click and transfer to PolyWorks Inspector. I'll need to save it before it goes, which is fine. And it's going to transfer over to PolyWorks Inspector. Now, PolyWorks Inspector offers a more robust method of inspecting the volume, and it gives us a bit more flexibility as well. So how does it differ? Well, one, we have more control over the area that we actually want to analyze the volume. And two, we're not just limited to polygonal models. You can also measure the volume of a point cloud as well. So to find that tool in PolyWorks Inspector, what you'll need to do is you can find it under additional measurement tools here, and then right at the bottom there you have measure volume. Whilst you're in this tool, there are two different methods you can use. You can either use the data to plane method or the data to data method. First of all, I'm going to show you the data to plane method. The way that this tool works is you specify a reference plane and it will measure, it will generate measurement cubes up to where the data starts to begin. So these the sum of these measurement cubes is what gives us our volumetric measurement. So the first option we have here is to select a reference plane. You can select a standard coordinate system plane such as XY, YZ or ZX, or if you have a feature primitive, you can also use that in this selection. You'll notice when I come to the right hand side here and I hide my data model using this tool here, that my coordinate system is, I've actually lined it up in the center of the Guinness can here, and I have it so Z is pointing up. So I can actually use the XY plane in this case, and I want to measure the volume both above and below that plane. So I'll bring my data model back, again using that eye tool on the right hand side, and bringing my data back. Okay, it then asks me to specify a contour. Now, the contour is essentially a curve-based feature that will define the boundary of this volume. So curve-based feature, this could be anything from a circle to a polyline. In my case, I've actually got, because I'm measuring essentially a cylinder, I could use a circle as my boundary, but if you have a more kind of free-form shape, you might want to consider using a polyline. So I'll show you that method here. So I'm actually going to create the polyline from a cross-section. So to create that contour, I'll close down the volumetric tool for now, jump into my create cross-sections tool and create a standard cross-section. We're going to create this cross-section in the Z-axis at Z equals 0. And when I preview this, you'll notice my measurement zone appears in the 3D scene, and I can confirm that to create the cross-section here. All right, so that creates the cross-section, but we need a curve-based feature such as a polyline. So I'm going to create the polyline from this cross-section. First of all, by selecting the cross-section in the tree, going to features, changing my feature type to a polyline, and then changing the method to from objects. And because I have a cross-section already selected in the tree, it's going to know that I want to create a polyline from a cross-section. All right, upon hitting create, that polyline is now created, which is going to define the boundary of my volumetric measurement. Okay, now I'm good to go with this measurement. So going back into additional measurements, into measure volume. So as stated before, I'm going to use the XY plane here in order to measure. I'm going to use the contour as my polyline as cross-section 1. I can then specify a direction. So do you want to measure above the plane, below the plane, or both sides? Well, in my case, I've got volume both above and below the plane that I want to measure, so we'll use both sides. And then it's going to ask me to specify a sampling step. As I mentioned before, the way this volume measurement works is it generates cubes between the reference plane and the data object. And this sampling step will essentially dictate the size of those cubes. So we'll come back to this in a second, and we'll leave it at 1 millimeter for now. All right, there is a more section here if you haven't opened it already. And under there, you'll find some more advanced tools. So there's a tick box for fill holes. So as I mentioned before, a watertight model is the most ideal model you can use for this measurement. However, if you do, for instance, have gaps in your data, or if you don't have access to that modeler-like software, you might have holes in your scan. And PolyWorks, if you have this option ticked on, will actually fill those holes in order to carry out that measurement. So obviously you want that ticked on if you would like that hole filling option to be taken into consideration, or you can tick it off if not. If, for instance, you do have if you do want to fill holes, but you also have some larger holes on the scan that you don't want to consider in the fill hole in the volume measurement, you might want to use this max hole width to try and filter those larger holes out. Okay, we have another tick box here which allows us to consider the normals of a point cloud. So obviously we're using an STL in this case, so we're not using a point cloud, but if you were using a point cloud and you had normals, I would recommend you have this ticked on, as it will give you a more accurate measurement when it comes to measuring the volume, as it actually does some averaging in the background there. All right, so those are all the options that we need to specify before carrying out this measurement. But to view how this will be measured, you can hit preview. And you'll notice those cubes start to populate between that plane and our data object. So you'll notice that obviously because we used a 1mm sampling step, our cubes have a 1mm edge length. Okay, so I can have a little look around my scan here, and you'll notice when I zoom in on the bottom here, those cubes are fitting quite roughly to the scan, and it's struggling with these smaller areas here. So with regards to our sampling step, the smaller the sampling step realistically, so if I jump this sampling step down to 0.2 mil, if I turn NomLock on and click preview, you'll notice that those cubes then fit to the data much more accurately. Okay, so the smaller the sampling step, the more accurate our measurement. However, you just need to bear in mind that the smaller your sampling step, the more strain you're going to be putting on your PC, both in RAM and graphics card. So that's just one thing to bear in mind whilst calculating your volume here. Okay, you'll notice that we have our results here under the results section down here, which gives you a positive volume, a negative volume, a total volume, and a signed volume. So quite simply, positive volume is the volume above the plane, so you can see that in green here. Negative volume is, if I maybe turn it back the way upside down. So negative volume being the volume below the plane, total volume obviously being both of them, and the signed volume being the positive minus the negative. Okay, so you can view those stats here, but if you'd like to report on this, you can simply hit confirm. And you'll notice I've now got report 1, and when I jump into report 1, it's actually created a table of those results there. Okay, so because I have active formatted reporting as my report item destination, that table has gone straight into my report here. Okay, so that is measuring the volume from data to a plane. As I mentioned, there is a second method, which is measuring data to data. So you'll notice when I go into that volume measurement techniques again, so we have instead data to plane, we have data to data. This method is for measuring from one data object to another data object. So this volume measurement is quite useful in tooling, for instance. If you have a bottom tool and a top tool, and you would like to know the volume of the void in between the two, measuring from a plane won't be good enough in this case. So you want to measure from data to data. So I prepared an example here. If I jump into an existing project, where I've actually taken this scan and I've split it into two separate polygonal models, a bottom and a top, just for this example. So in order for me to use this volumetric tool, we'll go again back into additional measurements, into measure volume, and we'll change our method to data to data. We still need to specify a reference plane, even though we're not necessarily measuring from the data to the plane, we're measuring from the data to the data. The reason behind this is we do need to orientate those cubes. So the cubes, we need to know which direction they're growing in, on which side they're going to face. So we still need a reference plane there. Again, we're just going to use the XY plane. It's going to ask us again for a contour, so we need to again specify the boundary using a curve-based feature. So again, we've got our polyline here. And then you'll notice that all the other options are exactly the same as the measure from data to plane option. Okay, this time when I click preview, it's going to look very similar. It's going to give us actually a warning message. At least one data object must be used and selected. And that's because for this particular measurement to work, you need to have two data models and you need to have one of them selected. So I actually made a mistake there. So if we select Guinness can mesh bottom, you can either select the top or the bottom one. Again, we'll go back into our dialog zone and hit preview. It's going to measure from that data object all the way straight through to that second data object this time, as opposed to last time where it just measured from the plane. Just like last time, we have our results given here down in the bottom of the tool, but if you hit confirm, again, it's going to create report 1 here, where we can find our table of results. So that sums up the various methods we can measure volume both on PolyWorks Inspector and PolyWorks Modeler and Modeler Lite. So thank you very much for watching today's webinar. If you have any suggestions for future webinars, please put them in the live chat or contact us on our social media channels. You can contact us directly as well if you email support@3dscanners.co.uk. And if you want more information and services that we provide, you can go to our website, www.3dscanners.co.uk. So from all of us here at 3D Scanners, I'm going to wish you a wonderful St. Patrick's Day, and we'll see you in the next webinar. So for now, cheers.